Okay. Right. Now, during the presentation, that previous video, there was a name of a person called Andy Bettelstein. Does anybody know him? He was the founder of Sun Microsystems, and he was the first investor into Google. He invested $100,000 before Google started. He turned that into a multi-billion-dollar return. Whatever he touches turns to gold, and he was a founder of this. There's something magical about what he does. So if you want to follow somebody, just copy him. You'll be in the area of success no matter where you go, all the way through his life. And he still walks around today. He's a German guy, walks around with open-toed sandals, and he's a multi-billionaire. And he's an exceptional guy and very much into open source. So let's tell you a little bit about what's going on. Yeah? How many of you are familiar with the Open Compute project? How many? Just a few. How many of you could write, say, a quarter-page specification about something like an OCP server from Inspur? Is there any knowledge like that in the room? So just the Inspur people could do that. Okay. Now, this is not unusual. When I first started talking about OCP around about 2 years ago in Europe, and I got involved with this because I was a consultant to Facebook doing a big data center up in Luleå in Sweden. And I say a big data center, the data halls are 300 meters long and 100 meters wide, and there's 2 buildings and there's a 3rd building going in. I just believed that this technology would just eat the world. And I started to talk to people about it in Europe. And nobody had heard of it. Nobody. Today, when I ask for a show of hands anywhere in Europe, I get 50% of the audience. Whereas 2 years ago, if I had a big audience like this, it would be like I've seen here today. There'll be 1 or 2 people. And now you've got all these new businesses entering the market. We had a big conference this week in Amsterdam, the very first regional conference. And we had over 600 visitors, plus we had the biggest manufacturers in the world playing in this. And it's very, very exciting. And it's happening very, very fast. Let's tell you why it's happening. So this is me. I used to own a company that designed and built data centers. And I sold that around about 10 years ago. Because enterprise data centers doing things traditionally are disappearing at a rate of about 10% per annum. So if you read the Gartner report for this year, 2018, they predict that 10% of all of the world's enterprise data centers, these are data centers that are owned and run by a company like a bank, yeah? They're just closing. The reason they're closing is they cannot compete with what the hyperscalers are doing in the public cloud space. Now, what they haven't all realized is why the hyperscalers are eating them alive. And the reason the hyperscalers are eating them alive is the way they use open source software and open source hardware in such a way that they create these phenomenal efficiencies. Now, what's starting to happen, the telcos have adopted all these technologies. You'll hear from Nokia. Nokia's new portfolio is all based on open source hardware. And now it's moving into the enterprise space, public and private sector. So if you go and have a look at the new specification for the Swedish government's G-Cloud, they have a specification for 6 brand new data centres, which is going to replace 230 of their data centres, and it's all based on open source OCP and open source hardware. It's really radical. So the foundation only started in 2011. The first conference was just a few people in a room in Facebook's offices in California. The major summits that we hold today in California have about 4,000 people at them. OCP hardware accounts for a very large proportion of the global manufacturing of servers today, and hopefully you'll hear from Inspur the sheer scale of the business. You are not familiar with it because most of it is going into the hyperscalers, and it's only just moving into the telco and the enterprise space, but very quickly. If you want to get involved, it's like all the open source communities. You come up with an idea, you throw the idea into the community work with you to develop the idea, and then it goes through an approval process and gets approved. Then it gets published on the OCP website, and anybody can use it. You can take it, you can improve it, and you can put it back again. And it's exactly the same as you've got in the Linux Foundation and other open source software organisations. Got a bug problem. Oh, there we go, it's working. Brand new pointer, never been used before. Now we have certain principles that we work to. We have 4. Everything that comes forward must be better than what went before. If you come forward with a server that hasn't got a better energy efficiency than the one that was there before, it'll be rejected. Just to give you an idea, there's new European legislation coming through in 2020 for server efficiency. If you compared an OCP server like are you going to show some pictures of your OCP servers? When you see these pictures of these OCP servers, they're a funny shape, they're optimized for energy efficiency, and generally at idle power and low utilization, they will use half the energy of a traditional server. Now, this European legislation that's coming in is to do with idle power as part of the legislation. So in 2020, you won't be able to sell quite a few of the existing traditional servers because they will not comply. So you'll start to see withdrawal procedures. And in the last month, there's been quite a media storm from some big manufacturers who know this is going to be a problem. The manufacturers who manufacture into the OCP specifications, they've got a big smile on their face. They're really happy because they're way in front of all the legislation anyway. But there's some research that's been done for European government bodies called the Eureka project, and what they've found is in some large government data centres, servers are sitting idle for up to 80% of the time. So they need to attack the idle power thing. And there was a very interesting presentation at the summit in Amsterdam, the OCP summit this week, where Rabbi, the guy who kind of leads this initiative, with European Union representatives on the environmental side, were talking about this. And it's going to be quite transformational. Quite transformational. There was also something there about there are no tools. We make these boxes, they're toolless. There's a wonderful video on the YouTube channel for OCP, and there's hundreds and hundreds of videos. If you want to learn about this, just go on. There's thousands of hours of education. It's all available. If you want the specifications, you can come onto the OCP website, go into the wiki pages, you can download all the specifications. It's all there. But being toolless is quite good, because you can repair things really fast. So these servers that you'll see in a while, these cubby servers, we call them vanity free. You can repair everything on them and change everything on them in about 180 seconds, and you can probably do 80% of all the changes in about 60. And there's some wonderful YouTube videos like Yahoo Japan. They use hundreds of thousands of these servers. And there's a lovely video of this Japanese guy repairing, and he shows you just how quickly it is. You just pull them out, no tools, change, push back. You don't go to the back of an OCP rack. A traditional rack, you spend all your time on the hot side playing with hundreds of cables. You don't go to the back of an OCP rack. You only work from the front. I'll give you some numbers. Let's give you some numbers about savings on people. If you were in a big bank's enterprise data center, they would have roughly one hardware server technician for every 250 servers. If I took you into the OCP data centers up in Sweden and Finland, you'll find one technician for 250,000 physical server nodes. That's a 99% reduction in people doing hardware maintenance. It's just at a different level. And this is why everybody's keen. This is why the telcos are keen to have this. This is why Nokia are into this, because the telcos are demanding these kind of solutions. They're just so much better. Now, I'm not saying all these hardware technicians will be made out of work, because what we really need, we need software engineers, like the people in Warren. The big demand is for software engineers, so we'll retrain them as software engineers. Now, in order to kind of understand all this, you've really got to start to change your intuitive mindset of what a data center is, what a server is, what a storage array is, what a switch is, the way the structured cabling is done, the way you build the data center. It's very, very different. And mines have something in common with parachutes. They work a lot better when they're open. And this is key to getting into this. I spend a lot of time talking to large enterprises about the adoption. The business case is so easy to make. For example, it's 50% lower cost to build an OCP optimized data center compared to a traditional one, a traditional tier 3 uptime. So it's easy to make the case, but people still don't change because they just can't get their head into gear to move. So what you have to start doing, you have to start getting into reading the background about what's really happening. And what we have to try and do is break habits. So you really need to understand the psychology of habit and how you can take somebody out of a habit loop. When I first started in the foundation, my title was European representative. But after about 4 months, I realised it wasn't about teaching people about the technology, which was a lot simpler, a lot easier than the traditional. It was about changing intuitive mindset. So my new title is Reset Catalyst. And what I do, I'm resetting people's mindsets. So I feel I'm more like a psychologist, if you like, now than a technical engineer. That's where the issue is, especially in the traditional established enterprises. But it is changing. At the end of the day, the lowest cost, just good enough technology will always win. It's just the way it is. IT is just the cost of doing business. That book there, Crossing the Chasm, is all about how Disruptive Technologies Move Through a Market. Really good book. And I'll explain where I believe we think we are with open source hardware. There is a much deeper thing that you need to understand as well, and it's what's happening at the macroeconomic level, and I'd recommend that book called Zero Marginal Cost Society. This idea of collaboration is really changing fast. And there's something special about collaboration and open source communities on how fast they innovate. And I'll show you a slide soon, which just shows you how fast open source communities innovate. They make Moore's law look like a slow pace of innovation. Open source communities develop and innovate 3 times faster than Moore's law. This is a very good book, and it's about the disruption to society through these technologies which are escalating really, really quickly. Now, open source communities do things big in the beginning. This is the 70th anniversary of the world's first stored program control computer. You can go to Manchester University and see it, and if you ask them nicely, they'll let you play with it as well. And it was just a group of hackers in the university that got together and developed this. And then the rest is history. The Americans took it, and the rest of the world took it, and what we use today is all based on what these guys did in 1948. In fact, it's quite interesting. Can you see the frames that are in there that are holding the equipment? They're 19-inch relay racks. And I'll explain later why it's the most stupid thing in the world to use 19 inches today, because we're not holding relays anymore, we're holding something else. The first flight, everybody's heard of the Wright brothers. But why are they called aeroplanes? Why do we use the term fuselage, aileron? They're French words. Because what happened, the very first heavier-than-air machine flight started in America, and then the Wright brothers went into a kind of a crazy mindset about patenting, putting patents on the flight mechanism. So the rest of the open source community were working on it. They just withdrew to Europe, and all the innovations happened in Europe. All they did was the first flight, and the brothers spent 7 years just chasing patents to try and get some money. They were finished. People, when they get too focused on that, they kind of get distracted from the innovation, and the other innovators just overtake them. And there is an argument today with accelerated technology advancement that there will in the future be no room for patents, because it would take you too long to get the patent based on the innovation curve in the technology. And there's a very good presentation done by the guy Tael, who leads Google's Innovation Moonshot Labs. And he talks about this. As innovation goes fast, patents you cannot patent. Because by the time, if you delay for a patent on a technology, someone's going to come along and get in front of you and leapfrog you. So it's going to be quite an interesting time ahead. Now, I believe openness it's in our genomes. It's burnt into us. We're social animals. This is why we're so successful as humans. This is why we can live anywhere, because we collaborate. We can live anywhere on planet Earth, and soon we'll probably live anywhere. Well, we'll be on Mars soon and the Moon. Yeah, with what's happening with the rocket systems. And what I'm really saying is, all I'm saying is, we're just getting back to being human again. It's not about secretive groups, it's about open collaboration. There's some very good research coming out now, academic research, showing these characteristics. There's some very good papers. This is a YouTube link. Now, when you give the slides away, give them away as not as PDFs. These are actually PowerPoint slides. Click on this and you can run these videos. And this is a half-hour video all about academic research on openness and what's happening and how fast it's moving compared to traditional solutions. Now, on the 50th anniversary of Moore's Law, some Intel engineers did a little exercise. They looked at the performance gains in microelectronics and compared it to a 1971 Volkswagen Beetle. And they came up with these figures. And they said, if Moore's Law had applied to these cars today, and this was in 2015, that car would be doing about 300,000 miles per hour, 2 million miles to the gallon, and it would cost about 4 cents if it was going through the same development curve as Moore's Law. You think that's good? Oh, by the way, they withdrew the Volkswagen Beetle last month from production, so it's coming out and it's finished. It lasted, but not for long. Now what this is, this is a comparison of innovation, genomics against Moore's Law. Now you can see Moore's Law coming down here, the cost reduction over time. And then you've got this green curve that comes down, which is reducing cost at a rate of about 3 times faster than Moore's Law. If I wanted to have my genome mapped back in 2001, it would have cost me $100 million. Today it's less than $1,000 in 18 years. Tomorrow you'll be paying £100 or $100 to have your genome mapped to find out all about your family history. Why is that happening? Why are they so fast compared to Moore's Law? Something happened in the end of the last century in 1996-97 when these people got together to solve this problem of mapping the genome. They realised it was a huge problem, and they realised nobody was able to solve the problem as an isolated group. They realised they had to collaborate. This was the same thing that happened with the world's largest machine that's ever been built by humans, the internet. We got there because we collaborated. And what they did in about 1998, they came up with a declaration in Bermuda called the Bermuda Principle. And what that was, they would release everything within 24 hours into the public domain that everybody was doing. And this is what's really behind this level of rapid innovation. And you'll see all that stuff in the, if you go and have a look in that academic study. Okay. So my approach is, well, openness is going to win in the end. If you stay in the old proprietary solutions, the world's just going to eat you. And this is what I mean by this change in this intuitive mindset. Where is the world moving? And it's not just in information technology. I'll explain. Whichever market open source enters, it eventually dominates. This is from a conference just recently in North America, the Open Source Summit. This here is the chief executive from the Linux Foundation, which started in the year 2000. And this is the dominance now of Linux in systems. Supercomputers, 99% Linux. All the phones you've got on, if most of you will be Android users and not Apple users, because now Android has about 85% of the global market on mobile devices. And again, it's based on Linux, open source. It's just the reality, it's just a fact. This is, again, one story. Microsoft purchased GitHub. This is the repository for the Linux Foundation and all the open source software. They bought GitHub $7 billion a few months ago. Microsoft's infrastructure, their global infrastructure for Azure, is all open source hardware. Microsoft contribute more lines of code to the Linux Foundation than any organisation in the world. Since Microsoft has changed its traditional executives, the whole organisation has flipped. And if you listen to the chief executive of Microsoft today, and you cut him in half, he will have open source written inside him. It's flabbergasting what's happening. And in the OCP Foundation, Microsoft are the most open and running forward with some of the most innovative advances in the open source hardware community. Now, is it good business to be in open source? The fastest growing company in America is an open source hardware manufacturer. They're all a little bit crazy. They come across as kind of off the wall, a little bit like the Warren people, because they're doing crazy things. They're doing really crazy things which are going to disrupt existing flows, the existing traditional solutions. Every year for the last 3 years, this company has grown by 700%, a 7-fold increase every year. Now, some countries, and this is why I'm up here, because I think that Estonia has something really special going for it, and it's reflected in what's happened. You're one of the most digitised societies in terms of governments in the world. You're really leading edge. And I see that you're going to be the people that are going to move into this space first. Now, Denmark have moved into it. This is the Danish Data Centre Design Centre, and there's an initiative to encourage open source manufacturing because they believe that's where the future is. And there are 10 companies involved doing open source manufacturing. Go along to, if you're in Copenhagen, go to Copenhagen, or just Google open source manufacturing Danish Design Centre, and you will find lots of information about what they're doing. Because they've read the academic research and they know that this is going to be a better way of doing things. Oh, and that little bit there at the bottom. This is theirs. It says, the concept of open source is spreading like a wildfire in the world's leading tech companies, not just IT. What you find is, this is Tesla. This is a statement off of Tesla's website. So if you want to go out and make a Tesla car, then go out and make one. Because what he's realised, Musk, is that if you open this up, you just get this massive collaboration. People don't feel, they're not fearful of getting involved because of legal prosecution. And they take the product, they enhance it. There's going to be people taking the technology from Tesla and they're going to be doing better things on top of it. But he's happy about that because what it does, it explodes the electric vehicle market. The pie gets much, much bigger, and therefore his business gets bigger, even though he's got these innovators that are kind of working around him. And then there's no reason, if they're working in an open source kind of way, that he takes their technology and works on it and throws it back into the community. But the development in electric cars is quite amazing. If you just look at the amount of parts in these Tesla cars compared to a traditional car, it's amazing the difference and how simple these cars are. What I tend to find is when people get into open innovation, they develop products that are really quite simple. And you'll see it in some of these servers that you might see later. Operations, you get better products faster. So Inspur, sitting at the front here, they came out with one of the first new processors from Intel in an OCP server. I think you were number one on the launch. And it comes out so fast. If you look at Ethernet switches, from the point when someone threw the idea in about building a new 100 gigabit Ethernet switch in an open source community in OCP, from the point where the idea was thrown in to the point where they were being rolled out by the tens of thousands into the hyperscalers took 3.5 months. Now, if you look at the traditional kind of isolated vendor approach, it would take 8 to 10 times longer than that, really fast. And there's one company called EdgeCore, which you might not have heard of, which is part of the Acton group. And it's really interesting. When at the point when they got involved with the open community, their turnover, their sales was kind of dipping like this. And there's a guy, the chief executive, called George Taparian. Go and follow him, he's a very interesting guy. Their sales were going down, and then he has this graph on a presentation he does. He shows this line. The line is the point where he started to get strategically focused in open source. And ever since that point, their turnover's doubled every single year. And he's the most passionate person for open source hardware, and EdgeCore and Acton have more open source hardware accepted on the OCP Foundation than any other manufacturer. And their business is doubling every year. Very, very fast. They've just launched, 3 days ago I think it was, a new open source router which is going to be used by all the telcos in the 5G networks. Around about 6 months ago, AT&T declared that they're not going to use proprietary routers anymore in the new infrastructures. And they wanted someone to make 60,000 open source routers. Well, EdgeCore launched a few days, I think it's just days ago, and they've found that niche. Everybody's got to catch them. And that's the way it's going. The telcos are all moving into these open source environments. Now, where are we? When you start looking at the distribution of disruptive technologies through a market, you get the innovators. These are the crazy people, the Facebooks. Get the early adopters. In there, an early adopter, say, let's give you a big enterprise, Goldman Sachs. 90% of every server today that Goldman Sachs buys is an open source OCP server. And if the technology is going to fly, it jumps this chasm, and then it moves into this area here called the early majority. And this is where we are now. We're in this area here. We've just landed in it. And it's sometimes called a tornado phase, where you get all this energy, you get an intense increase in demand, but the supply channel is just not there. And this is the problem we're in Europe. We don't have big enough supply channel. I go and talk to all the big systems integrators who do the traditional stuff, and they don't want to get into this business because it eats their existing golden egg that they're kind of getting their income off. So what we're finding, getting all new companies coming in quick with big investment. There's a French company. It's just been purchased by an American company. It employed 13 people. It got purchased in the summer of this year. It got purchased by an American company. At the point it got purchased, they were selling 1,000 OCP vanity-free servers per week. 13 people. Put that into perspective, if I gave you the biggest systems integrator for server systems, server solutions in the UK, they employ about 2,500 people, and they're not even doing that business. Here's the problem though, when these small companies are growing so fast, they need investment. So this investment's coming in, this money's coming in because to grow them fast. So this tiny small French company, because they've got the investment from America, and that's where the money's coming from, the money don't seem to be coming from Europe. The Europeans haven't kind of switched onto this yet. And this American company have just opened up a 15,000 square metre new facility 20 kilometres south of Paris. And I can give you other examples. from the conference this week, we've got a new company with venture capital coming out of the Middle East that has started an OCP integration business in Poland. There's going to be a demo suite in 2 weeks' time. There's a huge amount of money pouring into them. And there are people, the big enterprises in Poland, who want this technology. So watch this space. Very exciting. Just to give you an idea that we are in this tornado phase, when I first started with OCP, I had 1,500 connections and followers on LinkedIn, and I was very well known in the industry. I'm acquiring connections at a rate and followers just on LinkedIn rate of 1,000 a month. And what this is a little app that I run, and it tells me how much time I spend on apps. This is the last 30 days. Just on LinkedIn, I spent 38 hours. And what it is, it's just dealing with this huge surge, this stampede of interest. With that tornado kind of crazy madness. And they're saying, how do I buy this stuff? Well, sorry, we haven't got a supply channel over there yet. And we have a real problem because we can't even deal with the global regions. This is just Europe is going crazy. I keep all the time getting inquiries from Africa, the Middle East. I just do Europe. OCP only employs about 6 staff and I'm only part-time. It's happening so fast, really fast. Just to give you an idea, OCP tripled their staff in the European region just in this summer. So the Vice President of Channel Development, Steve Helvey, moved to London this summer to try and develop their supply channel. There was a report published by IHS Markit in March this year looking at the development of OCP, and they're predicting by 2021 in Europe alone a five-fold increase by 2021, not far, five-fold increase in OCP revenues. So we need big manufacturers that can supply the gear, and then we need the integrators who can make it work. Because you don't just drop this stuff in, it's just hardware. Someone has to put the operating systems on, put the orchestration layers on, the OpenStack, set up all the clever stuff on top. And I think there's an opportunity for people who are really clever at the integration software end. Yeah? So what I'm trying to recruit here, I'm not trying to really recruit adopters, I'm trying to recruit people to come into the supply chain. Yeah? If we look at Linux, started in 2000, today it's over 90%. If you look at hardware adoption, OCP gear, kind of ramping on a similar curve, if you like, similar growth trajectory. And then we get this trickle-down effect. The over-the-top hyperscalers, the telcos have gone for it, now it's going into the enterprises and governments. What does it do to the data center? It just eliminates all the stuff in the data center. This is a traditional data center. You've got centralized UPS, you've got chiller systems. You don't need all this in an OCP optimized data center. It all goes, you take it out. This is why the capex of building a data center for OCP gear is half the price. And when you consider that to build 1 megawatt of facility, data center facility using the traditional is somewhere between $8 to $10 million per megawatt, you can do it for $4 million a megawatt. It's a huge saving. Now, we don't keep looking at just hardware redundancy anymore. Because you're using software and you're using Linux containers and you're floating instances across resource, you don't really care if you lose the rack. You don't care if you lose a server. And I do like this little cartoon. We don't even care if we lose a data center. And is the rope really necessary? This is the approach. And it's having a big impact, the idea of uptime tier 3 data centers. The Uptime Institute are now trying to work out a new standard on how you define availability when you include the software. They're struggling. Nobody knows how to do it at the moment. Perhaps when Nokia get up, they can tell me how they're doing it, but at the moment we don't know how to define it. What happens as well, just how quickly things happen. This is a new project that started in March this year, a modular data center that they're working on. Because we have these multiple projects. One of them's called Data Center Facility. And this started, and already, just within months, the specification design on it, which again is open sourced, is seeing a 66% reduction in the cost of building modular data centers compared to the traditional data centers that used to use the containers. And probably by the end of next year, it'll be an 80% lower cost. This is really going to disrupt the data center industry. Anybody who's in the modular data center business is not on board with this, are going to be eaten alive. And the funny thing is, none of the really established players are involved on it. They can get involved, but they're not. Because there's the big companies will just continue going the way they've always gone until they get undermined by all this this technology, and then they'll be broken up. They just will not get involved. It's just something the way it is. The traditional businesses have to just keep going along like a big ship. But that means there's opportunity for small companies coming in underneath. These are the kind of things it takes out. Now, you need to kind of understand that you have to understand the history, where we came from, on how we started to develop data centers in the first place. And there's a lot of legacy there that we still do, but you don't need to do it. Let me explain. Why do we use 19 inches? Because these electromechanical relays that we used to use on railway signalling systems and early telegraphy systems fit nicely into a 19-inch framework. But we don't put those in data centers today. What do we put in data centers today? We put these things in. That might be the module. This module here is 4 inches across. It's a standard drive. Look at this. If you widen the rail very slightly, I'm not making the cabinet any bigger. I'm just not using 19 inches and I'm making it slightly wider. I get 5 of these in. 1, 2, 3, 4, 5. In a 19 inch, I only get 4. Therefore, in the same physical volume of a rack, 25% more. There is a negative to this. It gets very heavy. It gets very heavy. These racks weigh about 1.5 ton. And here's the problem with the existing data centers, especially the colos. They can't accept racks at 1.5 ton burning more than 10 kilowatts each. I spoke to a player in the hyperscale space at the conference this week in Amsterdam. They're now installing 36 kilowatt OCP air-cooled racks. This will happen in all the other spaces as we move through. So the next time you click on a search engine, you're going through these 40 rack clusters with 36 kilowatts in the rack when you do a search engine. So you can guess who it is. Just makes sense. Using space. Now this makes sense. I've got a module, and then I build the container. We've been doing it the other way around for years. We've got this 19 inches and we're bending all this sheet metal with a server to try and make it fit. bonkers. This is why they're not energy efficient, because we compromise the physical shape of it and we can't get airflow through it. To me, it's just a 14-year-old should be able to do this, but this is what I mean by people are stuck in this routine in their minds. Oh, there's another thing that makes me laugh about 19 inches, and that's that in medieval beehives, they used to use 19 inches as well. Let's have a look about the rack unit. Now, in an OCP rack, the rack unit's taller. So the rails are slightly wider, but the rack unit's taller. Now these are 40mm fans in a traditional server, using what we call the EIA rack unit, which is the small rack unit. And this is an OCP server. And hopefully you'll see some pictures of these. So we changed the physical shape of the server and we use bigger fans. And then there's something that I learned when I was 16 at school called the fan cube law. And what the fan cube law is this: if you reduce the speed of a fan by 50%, you reduce the energy to spin it by 7/8. So if you look at the energy required to push air through that server at the top compared to this one, this uses about 1/10 of the power or the energy as this one up here. And this is one of the reasons why OCP servers are very, very efficient at low utilization. Because as the power requirement on the CPU drops, it's all the overhead that causes the problem, like the fans. Simple stuff. If you make the rack unit taller, you can get bigger heatsink on the CPU, therefore it's easier to get heat off of it. If you cram it like into a pizza box, like a pancake, you've got a problem. So it's just re-looking at everything about the design. Not being stuck in traditional practices which are based on relays. Now, why do we put all the cabling interfaces on the back of the server? Because all a server is, it's a desktop PC that somebody picked up because they had too many on the desk and they started racking them. And all the cables are on the back because when you've got a device, might be a desktop PC or a Tael PC, the cables want to go out the back to fall out the back of the table. So they started putting them all in racks, and that's what they did. Well, the OCP guys, they said, no, let's put it at the front. Why do we want to stand at the back in all this heat? Let's do it at the front. So in an OCP server, there are no AC to DC power supplies inside them. We don't do out-of-band management in the same way. Out-of-band management is not done via multiple Ethernet ports from top-of-rack switches. Yep. Why do you have the keyboard, video and mouse interfaces when you never use them in a data center? Take them out. Why do you need a graphics unit in there? Nuts. All costs money. So what an OCP vanity-free server is, it's just a server that's stripped down to make a server that's optimized for a data center for someone to stand at the front and work on it quickly and easily and effectively, and to substantially reduce the waste. If you compare the 40 server OCP rack configuration compared to a traditional one, just all the tin that you take out reduces the weight of the rack by the equivalent of an 18-stone man sitting on top of the rack. He's just throwing rubbish away. It's just stupid. And on the front, you just have one or two Ethernet ports. Why do we use access floors? Because in IBM mainframe days, they were water-cooled and we run the water pipes under the floor. That's why we did water. That's why we had... It's the most stupid thing in the world to run cool air under the floor because you take no account of air buoyancy. What's the best way to put cool air into a warm room? It's denser, you pour it in from the top. If you push it in from the bottom, you have to use more fan energy to make it go upwards. Why tight control on humidity? Because we used to stick people on them. Do you know why we had tight control? Because we used to have printers in the room. And if you don't keep this paper within a certain tolerance on humidity, it used to curl up on the edges and it would jam in the printer. The way we used to feed the program into a machine, we used to use a piece of paper, a piece of card. We don't do that anymore. But people still persist in doing this. And the energy that's used is huge. This is a typical 40U server. And I'm going to rip it to pieces and turn it into an OCP rack. So I've got 40 servers in. There's all the little fans, those orange things. And I'm just going to take all the stuff out that we don't use today. Take out all those little fans. Take out all the AC to DC power supplies. Take out the top of rack switches, some of them, because we don't use out-of-band management in the same way. We actually do it through the bus bar at the back. And by the way, we do it with a Raspberry Pi for $25, not thousands of dollars using switches. These green things at the back are the what we call the IEC power strips. Some people call them intelligent power strips. They're $1,000 each. And in a 40 server rack configuration, you'd have $4,000 minimum of them in the back. OCP rack, you don't have them. You throw them away. Now, I don't know whether you've noticed, the manufacturers of these power strips, all the American manufacturers have sold their businesses. And if you go and study who they've sold them to the Europeans, who have got no idea what's happening, and they've bought these companies. And the Americans have gone away and started new businesses in an area where there's going to be a future. Quite interesting. This is just dead business. This here is the downflow crack. You don't use downflow cracks. Don't use that anymore. You don't run the air under the floor. You can use a loose floor, but you don't need to. All that grey stuff was the cables under the floor. There is a considerably less cable inside an OCP data centre. There are no copper permanent links in an OCP optimised data centre. It's all done with fibre. And what you've done, you've thrown away all this stuff. Now that's somewhere, you know, that's $10,000 to $15,000 worth of gear you've thrown away, just on one rack. And that's not including all the centralised UPS stuff that I've thrown away as well. So you can see these numbers are huge. But you're looking at something like a saving per rack compared to the traditional, anywhere between $30,000 to $50,000 to stand a rack in the data centre. Now, I'd just like to say, I hope I've disturbed the way you've kind of intuitively believed it should be. And what this is, it's called the Kubler-Ross change curve. And it's to do with what happens when you lose something close to you. And what happens, your performance changes over time. So let's imagine you lose your favourite dog, or someone close to you, a close relative, dies. You go into shock, you go through a phase of denial, you get angry, and then you fall into a depression. You kind of have to go through these emotional stages. And then you get to acceptance. And once you've got to acceptance, then you start to integrate again, start to create a new life, and your performance goes back up again. So all I hope from this, I've killed some of those intuitive babies that you had before, and that I leave you here. And the reason I want to leave you here in this state of depression is because part of the problem why lots of companies are really in trouble is they can't get through the other emotional positions. They're angry about what's happening, they're shocked, and they're in a state of denial that the world's changing around them, and they're the ones that are going down the pan. If you can get yourself depressed, then the only way is up. And I'll leave it there. Thanks for your time. hope you found it useful. Cheers.